little vocab review. Okay, now if I have a number line here, and this is red, so don't write this. If I had to say that, well, here's negative 3, and x is going to be greater than negative 3, it would head to that direction. Here's positive 3, and if I said, well, x has to be less than 3, it would head in this direction. Now, if this is an AND statement, I would only be able to deal with where they intersect. And I would not have any values past here, and I would not have any values over here. Now, that makes this different from a union. So if I were to say, well, x is greater than negative 3, or x is less than 3, so if it can either be that or the other, then it's okay for it to have positive 4, because positive 4 is greater than negative 3. Sure, it's not less than 3, it's not less than 3, but it's a whole ordeal. So as long as it's one of those two situations, you're good. So the interesting thing about these is that if it's less than negative 3, greater than negative 3 or greater than 3, that means this goes on forever, that goes on forever. So if I were to graph this on a number line, I'd start by, maybe having like a circle closing it in over here, but then I would shade all the way to the right forever. And then I would do the same thing over here and shade all the way to the left. So really what that means is it's infinite solutions. It can be anything. So it's basically your entire number line. So sometimes that happens with these OR situations. And when you put a couple things together, that's kind of what they mean by a union. So these are going to be unified. They're going to be put together. Okay, solve each inequality and graph the solution set. Now, just like our bookwork or whatever we do, let's rewrite these since they give us 3 problems back to back. Negative 3h plus 4 is less than 19. My other problem is 7h minus 3 is greater than 18. And this is an OR statement, so let's get that in there as a reminder. By recording that from our bookwork, we're ensuring that we're less likely to make a mistake. No real need to talk about how to do each of these. You've done them at this point multiple times now. So here's negative 3h is less than 15, dividing both sides by not just 3, but negative 3. And since we multiplied or divided by a negative, we have to switch the direction of our inequality before we write the final result. And if I look at that, negative 3 times negative 5 is positive 15, plus 4 is 19. We're good there. I could also say, well, 0 is greater than negative 5, which would drop this term out, and 4 is less than 19. We can check that just there. It's good. Okay, moving on to the other one. We got 7h minus 3 is greater than 18. Add 3 to both sides. Gives me 7h is greater than 21. I'll divide both sides by 7, and I'll say h is greater than 3. And as I look at this, I'm going to have a much clearer understanding of what this looks like if I draw a number line. Many of you will be able to figure this out just based on the math and the way it's written, but I still want to see the number line to strengthen your understanding of the concept. So here I am with h is greater than negative 5. Maybe just a slight arrow for now, lightly drawn with pencil. The other thing I'll say is h is greater than 3. Again, writing that sort of lightly with pencil. Now I know that some people like to present this like that just to kind of make it more clear how this gets smushed together. But let's think about this point here, and I won't talk at length about this in every example, but I will here. That's where h is 3. Well, if this is an OR statement, it doesn't work to say that h can be 3 on this inequality. But because it's an OR statement, is 3 greater than negative 5? It totally is, so it works over here. So now that means that if I wanted to shade, this would keep going and then overlap and fill that in So it's really just one arrow to the left. I'm sorry, to the right. So if you want, actually no, not if you want. Now I want you to erase that or clean it up a little bit so that we only have one arrow being shown to the right. Now if that throws you off a bit, you can pause this, give it a little bit of time to process, and if it's still confusing, seek me out and let me know what feels weird about that, and we can look at that with more of a breakdown. Okay, a plus 1 is less than 4, or a minus 1 is greater than or equal to 3. In the first equation, let's subtract 1 from both sides, and a is less than 3. Let's think about that. 0 plus 1 is less than 4. We're good there. I can also check 3. 3 plus 1 is 4, and that's right there at that crossroads. On the other one, I'm going to add 1 to both sides, and I'll have a is greater than or equal to 4. Okay, checking that crossroads, 4 minus 1 is 3. We're good there. I could also try an extreme example like 100. Well, 100 minus 1 is 99 is greater than or equal to 3. So we're good there. Same deal as last time. This is an OR, and we will have a better understanding graphing this. I'm choosing 0 to 5 with 1, 2, 3, 4 tick marks. First of all, a is less than 3. Good there. And then we would say a is greater than or equal to 4. So here I would have a closed circle and draw to the right. Now let's try to get this into one unifying statement. Well, we can't. We can't really do that. We would have to end up saying this or that, which is basically the problem we began with, so there's no reason to really rewrite it. We solved each and we graphed. Above the number line in the one before, though, we could just say, h is greater than negative 5. That's the solution set to this OR requirement. Third problem says x is less than or equal to 9. No algebra involved in solving that one. Or 2 plus 4x is less than 10. So like I said, there's no algebra involved here. There's nothing to talk about with checking. We could just put this on a number line right away. But first, let's solve the one on the right side. So I see 2 plus 4x. I'll subtract 2 from both sides, leaving me with 4x is less than 8. And then I'll divide both sides by 4. And I'll say, well, x is less than 2. Well, 2 plus 4 times 2 is 10. We're good there. And then if I plugged in 0, it would end up being 2 is less than 10. So we've made no mistakes here. The number line part. I have more room over here because of the way I've written the problem. So I'll get myself set up there, and I'll show 0, 10, 5 in the middle, 1, 2, 3, 4, 6, 7, 8, 9. And then I'm going to say, well, it's less than less than or equal to 9. But it's also got to be less than 2. We're good there. I kind of skipped around a little bit there. But I mean, x is less than or equal to 9. That covers it all. Since this is an OR statement, it doesn't matter if it's equal to 2. Even though it doesn't agree that it can be equal to 2 in this one, it does agree that it can be equal to 2 in this one. Similarly, I can talk about like a value like 5. 5 does not work here, but it does work here, so this overlap is totally fine. Few different types of problems showing up here. This is going to be the homework assignment. I think it should go pretty well, and let me know if you have any questions.